Hello and welcome to the next video in my series taking a more mathematical look at the economics you look at both IB level and A level. A full list of topics that I'm covering in this video series is on your screen now. But in this video, what I want to look at is the relationship between marginal cost and average total cost at the point of productive efficiency. So this video follows a specific exercise. I recommend that you try and do the exercise before you get the answers from this video. And the first question asks us to look at our total cost function there and identify fixed cost. So remember, the definition of fixed cost is cost which does not vary with output or quantity. So you can see here, out of these three terms, a constant term here which does not vary with quantity is plus 40,000. Okay, so fixed cost equals 40,000. And the second part of the question asks us to work out variable cost. Okay? Variable cost does vary with output and it asks for your answer as an expression. So here we are looking at this bit in here. So your variable cost is going to equal 20q cubed plus 10q. And now for marginal cost. Well, marginal cost, remember, is the cost of producing the next additional unit, i.e. how does total cost change with respect to quantity. So for this we need to differentiate with respect to quantity, we need to differentiate total cost. Okay, so differentiating total cost multiplied by my power gives me 60q squared plus 10. Okay, so the next question asks us to work out average total cost as an expression. So average total cost, remember, is your total cost divided by quantity. Total cost divided by quantity. So all I'm going to do is divide my total cost function through by q, which gives me 20q squared plus 10 plus 40,000 over q. And I'm going to rewrite that last term to make things slightly easier when it comes to my differentiation. I'm going to rewrite that last term as 40,000 q to the minus 1. Now we need to work out the quantity at which average total cost is minimised. So looking at your maximums and minimums, you set your first derivative equal to 0. So first of all we need to differentiate our average total cost with respect to quantity. So if I find my first derivative, differentiating what we have here, which gives me 40q, your middle constant term disappears, and then I get minus 40,000 q to the minus 2. Okay, so now if I set this equal to 0, I get 40q minus 40,000 q squared, q to the minus 2 equal to 0. Solving this, how do I solve it? Well, I need to multiply through by q squared to give me 40q cubed minus 40,000 equal to 0. And now I can just move 40,000 over to the other side, divide through by 40, which gives me q cubed equal to 1,000. So q equals the cube root of 1,000, which is just equal to 10. Okay, so now we've found out the quantity which minimises average total cost. I can do the next bit of the question, which says what is the minimum value for average total cost. So what I'm going to do is substitute in this quantity here into my average total cost function. So q equals 10 implies that my average total cost is going to equal, so I'm substituting it into this expression here, so 20 times by 10 squared plus 10 plus 40,000 over 10, which gives me, 100, that's 2,000 plus 10 plus 4,000, which gives me 6,010. So now to answer the last bit of the question, what is marginal cost at the point of productive efficiency? So I've got my marginal cost function here, and all I'm going to do is substitute in that quantity of 10 that we worked out into my marginal cost function. So I get 60 lots of 10 squared plus 10, which gives me 6,000 plus 10, which gives me 6,010. So all we notice here, well, that value of 6,010 is exactly what we had previously for the average total cost at the point of productive efficiency, which explains why we have this relationship here where marginal cost crosses average total cost at this bottommost point of average total cost, i.e. marginal cost crosses average total cost where average total cost is minimised. So it's important to note that I defined that original cost function, your total cost function, very carefully. We had that cubic function. And the reason why I did this is because that represents the law of diminishing returns, i.e. as quantity increases, your costs increase. If this wasn't the case and I chose another function, say a reciprocal function or something else, then this wouldn't come out like this, where we have this nice result and where marginal cost crosses average total cost at the bottommost point. Thanks for watching my video. Feel free to check out some of the other content available on my channel, or you can leave me a comment if there's anything in particular you'd like to see.